Hi everyone, in this video I'll be explaining on how to design an op-amp in LTSpice. So this specific op-amp is built using organic MOSFETs, technically organic thin film transistors, and this is from this paper, printed 5 volt organic operational amplifiers for various signal processing. So this paper gives the model that they have extracted for their device. So I'll be using this model file to design the operational amplifier. So the first step is to use these PMOS 4 models from LTSpice library. You just import them and change the model name from PMOS to POFET. That is how I have saved the MOS transistor. And as you can see, I have written the model file. Dot model represents that this is a model file, and POFET is the P-type organic field effect transistor. And this is the exact model file that has been written down in the paper. So I'll be using this. So this is for the P-type OTFT and this is for the N-type OTFT. I'll just explain what each of these terms individually mean also. So level 2 basically refers to the type of spice model that will be used in simulating the transistor. So level 2 is the bulk charge model, and L equal to 45 micro tells us that the channel length is 45 micro. Similarly, W equal to 900 tells us that the width of the transistor is 900 micro. So U naught is technically the low field mobility, that is 0.07. Tox is the oxide thickness, 280 nanometer. VTO is the threshold voltage at zero bulk source, so that is -1. NFS is the surface concentration, and CGSO is the gate source overlap capacitance. Similarly, CGDO is the gate drain overlap capacitance, and lambda 0 is the channel length modulation parameter. These are standard terms associated with MOSFET modeling. So this is the model file for the PMOS and this is the model file for the NMOS. And I have saved it in exactly the same directory where I have created my schematic. I have saved it as pfet.mod and nfet.mod. And this is my schematic file, .asc file. And this is my schematic. So the paper here builds the op-amp in this fashion. This is a standard single stage operational amplifier. You have this current source between this node Cur and VSS, and this is a mirroring PMOS that mirrors it to the other two PMOSFETs, and this is the input stage and this is the output stage, a two-stage op-amp. This is the single stage and this is the output stage, and all the P MOSFETs are taken to be identical. Similarly, all the N MOSFETs are taken to be identical. I am using the term N MOSFETs and OTFT interchangeably here. So just going forward, so I have created the schematic and I have created the symbol also. So just going to the schematic, go to hierarchy, open this sheet symbol. So this gives the symbol. And using this symbol, I have built the open loop configuration that has been mentioned in the paper. So you externally connect a 10 nanoampere current source, you ground V in. V in basically is VIN, that is the negative input, and VIP is the positive input. I will vary VIP between minus 2.5 and 2.5 with increments of 0.001 volt. And the op-amp uses dual supply with VDD being 2.5 volt and VSS being minus 2.5 volt, and this is the Vout terminal which I will be tapping. And now I will simulate this. As you can see, this is the open loop characteristic of the organic op-amp. So this is what has been described in the paper, and we are able to successfully reproduce the plot. And so this basically gives an interesting intersection between organic transistors and designing an op-amp in SPICE. So thank you. Hope this helped.